In this video, I am going to tell you basics of philosophical logic. Philosophical logic is a study of reasoning and principles that lead us to form valid arguments. So first of all, what is logic? It is the study of correct reasoning. It helps us determine whether the conclusion is following the premise or not logically. For example, the first premise is that all humans are mortal. Premise 2 is that Ajamya is mortal. And the conclusion that I went into is Ajamya is human. Well, this does not work because many other things can be alive and the subject can be anything else, not necessarily a human. And this is called affirming the consequent fallacy. If we go like all cats are mortal and the second premise is Augie is a cat, then the conclusion can be made that Augie is mortal. This one is not false because it follows the premises. The basics. The premise, it just means that statement that provides reason for conclusion. The conclusion is a statement that logically follows the premises, and arguments are a set of premises leading to conclusion. There are two types of logic. The first one is deductive logic, where the conclusion necessarily follows the premises. If premises are true, then the conclusion must be true. And the next thing is inductive logic, where we deal with the arguments where the conclusion is likely but not guaranteed. For example, we can see the sun rises every day and it is recorded that it rose every day in the history. And the conclusion is the sun will rise tomorrow. The conclusion is likely but not guaranteed. Now we are going to see another basic concepts. First one is validity. Validity, an argument is valid if the conclusion logically follows the premise, regardless of the truthfulness of the premise. Contradiction, a situation where a statement and its negation are both claimed to be true. For example, A is B and B is not A. This cannot be happening simultaneously. Now we are going to talk about connectives. The first one is AND, which is represented by this. And here both the statements must be true for the expression to be true. The next is OR, where we represent it with something like this. It almost looks like a V. At least one of the conditions must be true in this. And the last one is NOT, inverted L you can say, and it negates the truth of a statement. Now let's look at the conditional statements. This helps us to explain cause and effect relationships. We can say if P then Q, then it will be P then arrow and then a Q. Here P is a condition called an antecedent and Q is consequent, which is also called, can be called conclusion. Example, if P is equal to 1 plus 1, then Q is equal to 2. And we can show it like 1 plus 1 is equal to 2. Here P evaluates to be true and so does Q. Hence the hence if P then Q, implication holds. I am not going to tell you and elaborate the table. You can watch several videos, but I am just going to put them around the corner so you can see it. Contraposition and inverse. Contraposition of if P then Q is not Q then not P. And let's see this with an example. Original, if it rains, the ground will be wet. And the contrapositive is if the ground is wet, it did not rain. This is P, if P then Q, to if not Q then not P. Contraposition is always logically equivalent to the original statement. The another one is inverse. Inverse of if P then Q is if not P then not Q. For example, if it rains, the ground will be wet. But if it doesn't rain, then the ground will not be wet. These are not equivalent because the reasons for ground to be wet are many. Now let's talk about the fallacies. The first one is affirming the consequent. The fallacies occurs when one assumes that the consequent is true and antecedent must be true. And the next one is denying the consequent. This fallacy occurs when one assumes that because the antecedent is false, the conclusion must be false too. Now let's talk about quantifiers. The first one is universal quantifier. It indicates that a statement applies to all the members of the domain. For example, all humans are mortal can be shown as this. Another one is this reads as VA notes as for all x, HX represents x in human, MX represents x is mortal, and this totally reads for all x, if x is human then x is mortal. Existential quantifier. This indicates that there is at least one member for which the statement is true. For example, this and this reads as there exists an x such that x is a human and x is tall. Now let's look at the modal logic. It introduces possibilities and necessities. Necessity is a statement if it is necessarily true in all possible words. For example, 2 plus 2, it is necessity. And the next is possibility. A statement is true if there is at least one possible world where it is true. For example, it might rain tomorrow. Now, it doesn't matter where it will rain, but it still is true. The next is predicate logic. It extends propositional logic by dealing with predicates and quantifiers. It allows us to create and express complex statements. What are predicates? These are functions that return true or false. For example, is x human? It can be either true or either false depending on the x. We can use them in quantifiers. For example, as you can see here. And last but not the least, formal proof system. These are the systems used to derive conclusions from premises using a set of rules. They help us understand the structure and logical arguments and verify their validity.